Lesson 5.8, Graphing Absolute Value Functions. The objective of this lesson is to graph an absolute value function and to translate the graph of an absolute value function. Absolute value function is a function with a V-shaped graph that opens up or down. The parent function for the family of absolute value functions is y equals the absolute value of x. It's like the starting point. Piecewise function has different rules for different parts of its domain. A step function pairs every number in an interval with a single value. The graph of a step function can look like the steps of a staircase. Translation: a transformation that shifts a graph horizontally, vertically, or both. The result is a graph of the same size and shape, but in a different position. Essential understanding. You can quickly graph absolute value equations by shifting the graph of y equals the absolute value of x. Problem 1. Below are the graphs of y equals the absolute value of x and y equals the absolute value of x plus 2. And how are the graphs related? So on the left-hand side here, we have the absolute value of x. And on the right side, we have the graph of y equals the absolute value of x plus 2. The graphs have the same V shape. Notice each point on y equals x plus 2 is 2 units higher than the corresponding point on y equals the absolute value of x. So the graph of y equals the absolute value of x plus 2 is the graph of y equals the absolute value of x, the parent function, translated up 2 units. So we can say here that if you have the absolute value of x and you add a number onto it, it's going to be moved up that many units. And if it's minus a number, it's going to be translated down those units. And that's what we see here. So the graph of y equals absolute value of x plus k is a translation of the parent function. If k is a positive number, y equals the absolute value of x plus k, translate the graph of the parent function up k units. And if it says minus k, it's translated down k units. So let's look at problem 2. What is the graph of y equals the absolute value of x minus 2? We know the equation of the absolute value function, which is right here. We need the graph of this function, okay? Let's identify the direction and amount of the translation, translate the y-intercept point and one point on each side of it, and draw the graph. So if we start out with the absolute value function, which obviously do the best that you can, all right, that's the beginning. That's the y equals absolute value of x. Now we need to draw the graph of y equals the absolute value of x minus 2, which means we're going to take the y-intercept 0, 0 and translate it down 2 units. That's going to be our starting point. And remember, do the best that you can to make it look like a V. Graphing a horizontal translation. For a positive number h, y equals the absolute value of x plus h translates the graph of y equals absolute value of x left h units. This is important. And y equals the absolute value of x minus h, translate the graph of the parent function right h units. This is the opposite of what we just saw when we had plus k and minus k. So, if you have plus h inside the absolute value symbols, you're actually going to translate it left. If you have minus h inside the absolute value symbols, you're actually going to translate it right. So problem 3, what is the graph of y equals the absolute value of x plus 5? So let's it says draw the graph of y equals the absolute value of x plus 5 by translating the parent function left 5 units. If there's a plus sign inside the absolute value, go to the left 5 units. So we know that the absolute value function is this, something like that. And we are going to translate it, move it to the left. 1, 2, 3, 4, 5. That's going to be our new center. And remember, do the best that you can. Make it look like a V. Okay? The horizontal translation is a little more difficult because you have to think opposite. Graphing a step function. The absolute value function is an example of a piecewise function. A piecewise function, again, is a function that has different rules for different parts of its domain. Another example of a piecewise function is a step function. A step function is a function that pairs every number in an interval with a single value. The graph of a step function can look like the steps of a staircase. Each piece of the graph is a horizontal segment that is missing its right endpoint, indicated by an open circle. So this would be a step function. Kind of looks like a staircase. Let's do a couple of problems. what is the graph of y equals the absolute value of x minus 7? So all we have to think here is there is no numbers added or subtracted inside the absolute value, so we don't have to think opposite. Outside the absolute value, it's going to be up or down. So we see minus 7, so we're going to translate it down 7. So the absolute value starts at 0, 0, and we're going to go down to negative 7, 0, which would be right here, and we would just draw. Obviously, when you guys do it, you're going to have a better drawing than this. So this would be the absolute value of x minus 7. Let's do a horizontal one. What is the graph of y equals the absolute value of x minus 5? Here we see inside absolute value, things are changing. So inside, you have to think opposite. So inside is either right or left, but think opposite. So I know you want to say minus 5 is going to go to the left 5, but you have to think opposite. It's going to go to the right 5. Because remember, it's inside absolute value. So the absolute value of x starts at 0, 0. We're going to go to the right 5. This is going to be our new center. And from here, do the best you can to draw a V-shaped line. Right? We will do more with this tomorrow, but make sure you get the important parts down, that inside the absolute value symbols, think opposite, left or right, but opposite. Outside absolute value symbols, up or down, and just whatever. If it's plus, up. If it's minus, down.